Okay. Lesson 9 is on parallel and perpendicular lines. Today is 9:25. So you've already seen parallel and perpendicular lines. When I say those words, you probably know what we're talking about. We're just going to take them, put them on a graph, and see what happens with them. So parallel lines, can anybody describe them to me?
They go on forever and they don't intersect.
Perfect. Parallel lines are lines that never intersect. Instead, they run the same direction side by side. So off to the side, let's just free-handedly draw two parallel lines, like this one and this one. I'm going to call them line A and line B. So there's two ways that math people write parallel without spelling out P-A-R-A-L-L-E-L. One way is on the actual picture of the parallel lines. If you see an extra arrow or triangle drawn on the lines, that means those lines are parallel to each other. It's one of those things where if it looks parallel but it doesn't say that, at some point in math classes we don't want to assume that anymore. The other thing is you could see this. That does not say A11B. That says A is parallel to B. That little 11 or pause button looking symbol just means parallel. So on a graph, lines that are parallel are going to have these same slopes. But they've got to have different y-intercepts. Because if they have the same slope and the same y-intercept, you don't have two lines that are parallel to each other. You have the same line. Let's just quickly verify that. Line 1, y equals 2x minus 5. What's the slope? 2. What's the y-intercept? Can some brave soul try to walk me through how to graph this? No. Just tell me. Tell me like I have never graphed something before. Started at -5? Right here? Right here? Yeah, okay. And now what? Perfect. So since the y-intercept is -5, start down at -5 on the y-axis. Since the slope is 2, we're going to go up 2 and right 1. Next one, y equals 2x minus 1. What's the slope there? 2 again. Y-intercept is? So it looks like we're going to have this line. Do you believe me pretty good that parallel lines got the same slope?
Yeah.
Cool. So, what we've got now, instead of just given two lines and proving they're parallel, instead, it says write the equation of a linear function in slope-intercept form that is parallel to the two lines above and passes through the coordinate -3, -2. Okay. We're going to need to use the point slope form. So that means we need a slope and a point. What's the slope got to be?
2.
If it's going to be parallel to the lines above, the slope has to be 2. Then the x1 is going to be -3, and the y1 is going to be -2. So there's the point slope formula. What number goes between the y and the equal sign? It's always really tricky to remember to switch these two signs. So y plus 2, what goes after the equal sign but before the parentheses? Just 2. What goes in the parentheses with the x? Plus 3. So these two, you switch the sign, but this one, you keep the sign. That's just a weird little quirk that we got to remember with that point slope formula. Then just distribute and get y by itself. 2 times x plus 3 is going to be 2x plus 6. Subtract 2, you get 2x plus 4. Any questions? Okay, can y'all help me set up the point slope formula for the next one? Here's my skeleton, but I got 3 numbers I got to plug in. For number 3, it says it's got to be parallel to 2/3 x plus 5 and go through 12 negative 9. So what number goes after the y? Is it y minus 9 or y plus 9? Perfect. Y plus 9 equals 2/3 times x, and then what? Minus 12. Distribute. What's 2/3 of negative 12? Negative 8. Do me a favor and try 4, 5, and 6. Be careful on 6. It wants them all to be parallel in slope-intercept form. Number 6, it gave it to you in standard form. Just a little hint there for number 6. Do y'all have any questions about those 3 answers? What's up?
How did you get 5 over 2?
So, back whenever we talked about the standard form, we said, hey, the y-intercept is always just this divided by that, the x-intercept is this divided by that. Well, the slope was always the opposite of the first number divided by the second number. So the opposite of 5 divided by -2, -5 divided by -2 is just 5 over 2. Now you could have also written here y equals 2.5x minus 12.5, 11.5. That works also. Questions? Okay. On the back, let's talk about perpendicular lines. Perpendicular lines are lines that do intersect at a very particular angle. The intersection forms what? Yeah, it forms a 90-degree angle, also known as a right angle. So here's 2 lines that look to be about perpendicular. So there's a symbol that we use to say, hey, these lines are indeed parallel. We put a little arrow on it. Do y'all know the perpendicular symbol?
Square in the front.
Yeah, a little square in that intersection. That's how we say, hey, that's a right angle. Now, the other way I could write this, A, that symbol, B. Looks like an upside down T. It just says line A is line A is perpendicular to line B. So, based on these 2 lines that I'm telling you are perpendicular to each other, 2/3 x minus 3 and -3/2 x plus 2. There's 2 things that are true about their slopes. What do you think those 2 things are?
The slopes are the same, they're just flipped.
The slopes are the same, they're just flipped? Okay, that is one of those things. Their slopes are reciprocals. You flip to fractions. So 2/3 becomes 3/2. What else happened? What else changed? One of them's positive, the other one's negative. They're opposites. So, line 1 has a slope of 2/3. That tells us to go up 2 and right 3, starting at the y-intercept -3. line 2 has a slope of negative 3 over 2. That tells us to go down 3 and right 2. Starting at the y-intercept of positive 2. Those two lines look perpendicular enough? Cool.
Stop.
Y'all, knock it off. Do we have any questions about number 7? All right, let's get through these next two and I'll let you practice. Number 8, write the equation that's perpendicular to 3/4 x plus 5 and passes through negative 12, 5. So I need a slope and 2 coordinates. The x1 and y1 are just negative 12 and 5. Now remember, we're going to switch those signs here in a minute. But I need an opposite reciprocal slope. The original slope was 3/4. So what's the perpendicular slope? I heard 4/3. So flip it and change the sign. Positive 3 over 4 becomes negative 4 over 3. Does that seem okay? Okay, all we did to get that slope was take 3 over 4, flip it, and make it negative. Now, if it was already negative, make it positive. So we've got y minus 5 equals negative 4/3 times x plus 12. That sound okay? Y'all stop me. Do we have any questions about how I set that up? Why I put the numbers where I put them? I can't tell if I'm just bad at reading faces today or if we're confused. Okay, if you need some help later, don't be afraid to ask. I'm going to keep on going. So distribute the negative 4/3. Negative 4/3 of 12. Okay, so 1/3 of 12 is 4, so 4/3 would be 16, right? So we've got negative 16. Add 5 to both sides. We get negative 4/3 x minus 11. Questions on 8? Okay. Number 9. The equation of a linear function that's perpendicular to negative 1/2 x minus 6 and goes through 4, negative 9. What is the perpendicular slope to negative 1 over 2? It's just 2. So if I take the slope -1/2 and I flip it upside down to get -2/1 and then change the sign, 2/1 is just 2. So the perpendicular slope is 2. This is y plus 9 times 2 equals 2 times x minus 4. Sound good? Okay, if you have a question, let me know. If not, go ahead and try 10, 11, and 12. Again, for number 12, you're going to want to have that little slope ratio. So I'll leave them right there in the corner. And if you want to check your work, here are those 3 answers. Any questions? I think so. Yeah. So for that last one, if you got 0.6 repeating, x plus 3.6 repeating, that's the same thing. Okay, on this practice, 1 through 10, I've just got 2 pairs of lines. All I need you to do is say, hey, are they parallel, perpendicular, neither? Here's the breakdown. There are 2 that are parallel, 4 that are perpendicular, and 4 that are neither. 2 that are parallel, 4 that are perpendicular, and 4 that are neither. (11 and 12) want 2 parallel lines. 13 and 14 want 2 perpendicular lines. 15 and 16, if you get 2 of them, they're extra credit. Yep. The 2 word problems on the back. 15 and 16 are bonus? Yes, sir. 2, 4, and 4, yep. Hang on just a second.
Don't tell my stuff like that.
Oh, I go use the bathroom.